Hello, welcome to UL. I am Senthil Kumar. I am a multidiscipline engineer. I am working on the physics, which is the parent for all the engineering domain, likely to be a mechanical, electrical, electronics, and even the computer science, the grandchild of this one. In the last lecture, I discussed about the force, because I took the first topic in my lecture is force, because that's a very important and very basic and very first root for this science and technology. And in the next lecture I took the topic called permeability, because permeability is a very important factor that we have to diagnose, and we have to make many queries on this permeability. We have to clearly diagnose the permeability so that we can take this our science and technology into the elevated growth in the sense of science and technology as concerned. So my objective is to diagnose and characterize the permeability. To diagnose and characterize the permeability by this case. This is what our aspects. We are trying to diagnose with the first foot, and until now we are just whatever we diagnose we discuss now. And in the fourth coming days also we will chewing this permeability. Whatever we have an innovative idea on this permeability, we will discuss in the forthcoming lectures. But this is the as of now. Our lecture is like this on this permeability. So with this first question regarding this permeability is, what is permeability at least, and what are the different kind of permeabilities that we have to query. So and then we have to characterize, we have to clearly understood so that we can make use of it, permeability by this case. And permeability is nothing but inter-object. For example, I have a system. Within this system I will have ample number of objects. Object 1, object 2, we will have n number of objects, uncountable number of, they have a meshing of this force. So it's like a meshing of this force. This force is like a meshing. So this force is a meshing of this force. It's the permeability is nothing but inter-object. Force. Second point about this permeability, it's like an potential energy, which is already present in this and the third property about this one is, so it is like a gain. Means if I am giving a permeability, I will write a simple force formula. F is equal to G into M1 M2 by R, ratio between multiplication of mass with respect to the square of the distance among this object. So it's a multiplication factor. So it's like a gain. It's like a gain because it's a multiplication factor. And it is a potential energy which is already present in the systems, likely to be a if I have this energy, for example, if you take the system, this is the force when every object will be already been tied up with each other. For example, I have a system. In this system we will have uncountable number of objects is present. If you take a small material within this material, we have ample number of binders, because each and every basic element in the system will be tied up with each other. If they have binded with this one, they have less tighted, moderate tighted, average tighted, good tighted, heavy tighted. So based on this object inter-object forces, they already been tied up with each other. This force we call it as permeability by this case. They already been tied up within the systems. This force will be called as permeability. This is like a potential energy, and this energy has been already been tied up within the systems. So with each other. So this is an inter-object force. It is inter-object. Within this system we have ample number of objects, and these objects are, all the objects are tied up with each other, and this is like a potential energy. This is whatever we have here, the energy, that energy already been present here, that are all tied up with each other. This is like a potential energy. When you give a small disturbance, it will affect the system of the bonding, so they are supposed to make a vibrate. For example, I have a system like this. If I am giving, if the system is lightly bonded, when I am giving any shock, any disturbance with this one, the bond will be vibrate. So when it vibrates, the signal whatever we are giving, that signal will be propagated in this case. If they are tightly bonded, if you are giving any energy, it may not vibrate, because it is highly tightly bonded. That we call it as high permeability, extremely high permeability system, that we call it as black hole. The black hole is nothing but extremely high permeability medium, that we call it as black hole in this case. Even if you are taking the center of the universe, the center of the universe has been with a black hole. That black hole has been clearly tied up with each other because of the heavy mass and heavy weight and heavy pressure, heavy mass in this case. With this mass, with this mass, they are tightly bonded. If you are giving any signal or any wave or any force, it cannot vibrate. It simply keeps like this. It cannot vibrate. Since it's not vibrate, the signal cannot be propagated. Usually the signal should be propagated by the disturbance. The bond has to be vibrate. If the bond has vibrate, then only the signal can be propagatable. If the bond couldn't be vibrate, the signal cannot be propagatable. That's why we are experiencing the black hole. It doesn't reflect, it doesn't refract. So it simply sit as like this. Whatever the signal we are giving, it doesn't respond. So if it is not vibrating, so that the signal may not be reflected and it may not be refracted. So it has been keep on in the holder in this case. So that's what we have to know, the first aspect of this permeability. And we will go to the next one. And what are the property of this one? So one we have to realize it by now is permeability exists every part of the systems. The permeability must exist in every part of the systems. Even if you take a microscopic or nanoscopic or femtoscopic, even within the vacuum or within the space or everywhere in the material, inside the earth, inside the planet, every kind of system, every kind of metal and every kind of water, liquid, solid, gas, vacuum, everywhere the permeability has been tightly bonded. And it is also some kind of attractive force. It will be comes under the force aspects. It's closely related to the force aspects, and this is already been binded together. Force is nothing but we are giving a momentum, and we are giving a force to force, and which will make some momentum. That momentum will make some vibration of the signal that will be propagated to the next system, and again it's been propagated to the next system. Likewise, it is propagating, and overall system we call it as a wave. The trajectory wave. When you are integrating the overall system trajectory by a graph, that looks like a wave. So wave is a wave. Through wave only we can transfer the energy from source to destinations. So permeability is spread everywhere. Permeability everywhere. It's like a potential So permeability is like a potential energy. It's already been tied up with each other within the systems. Even when you take a system, any system in the galaxy system or material or a solar system or any kind of systems, if it is a nanoscopic systems, atom, subatomic, everywhere the permeability has been binded. It's like the bond between within the objects which already been tied up with each other, and they are already been tied up, and this is, we call it as permeability by this case. And when I am classifying this one, I have to classify two: mechanical, and next one is electrical, And next one is magnetic. The mechanical we call it as capital G, that's a universal gravitational constant. In electrical we call it as mu permeability, and magnetic we call it as permeability mu. So both of them in this case. And this is the one. If this is a very basic classification of this permeability, the basic permeability will be clearly classified into basic three domain. As mechanical domain we call it as capital G, that is in the electrical domain we call it as mu, and magnetic domain we call it as mu. So this is, they have the system inside this one is tightly bonded to each other. With the system which has the objects which are tightly bonded together. They have already been bonded together each by this case. So it's like a meshing of this object, that we call it as bonding of this one, and they will be classified based on the bonding. We can classify to bonding classification. When we are classifying the bond, one is we call it as tightly coupled, loosely coupled. Tightly coupled and loosely coupled. This is the two basic kind of this permeability by this case. And next one is energy transfer. When you are transferring the energy, next one is energy transfer. In this case of energy transfer as concerned, when we are classifying about this energy transfer, we should have to go classification of the energy. The energy can be transferred through wave only. So this is a tiny momentum, force transfer, tiny energy transfer, that is by momentum aspects, where this small force has been transferred from object 1 to object. And if you continue to this whole energy transfer, the system will have, I have a system here and I have another system. This system will be acted here, that's a force, and already it is bonded with each other. When I am giving the small force to here, this will affect this entire aspects, entire relation of this one. So this may go for a vibration. So when it is go for a vibration, this will affects the neighboring one. They are also vibrating and they will affect this one, and again they are vibrating, so the signal has been propagated. When you make it as the graph, it may be an harmonic and it may be a square wave, it can be a sawtooth, or it can be a triangular wave, or it can be any kind of wave, or maybe any kind of wave, or it can be any kind of this wave, or maybe like this, or it can be a crust and trough. So this is crust region, this is a trough region, this is crust region. So this is like crust and trough. This kind of energy transfer is possible by inside an object. This kind of energy transfer is possible by inside an object. This energy crust and trough is possible by inside an object. Maybe the type of this one is solid, liquid, gases. Usually this is possible, and in some cases it's extremely less, but this kind of conservation is not up to this marks with this crust and trough is not possible. This is very by low propagation, and these two are good in this case of crust and trough. That's why the sound waves can be excellently propagated in the air medium, so than the solid medium. And next one is cross sectional wave. This cross sectional wave may be classified maybe in this surface of this one. This is inside an object, so this is longitudinal. The longitudinal wave will be propagated as a crust and trough. When it is propagated as a crust and trough, it might be in this case of inside an object only it is possible, but this harmonic may be in the surface of the object. Usually the harmonic might be in the surface of the object, so the energy will be propagated in the surface of the object. It can be in the mostly best in this case of solid. This will be very good performance in the solid and less performance in liquid gas. So this crust and trough is less in this case of liquid and gas and best in this case of solid and less in this case of liquid and gas. This is a very good performance in this. The cross sectional wave is usually performed excellently in this case of solid materials, and it may be not up to the mark in this case of liquid and gases. In the kinematic as concerned, these aspects are about to be called as in kinematic. Kinematic means mechanical. In this case of mechanical, the signal can be propagated by means of this, can be a harmonic in the surface, the crust and trough in the inside an object, and when you take this another kind of techniques, if you go for this another kind of techniques, we will have an electromagnetic one. This is magnetic, electric, mechanical. In this case of this one, this will be possible in both inside plus surface. In everywhere it is present. It can be possible in this case of inside the surface, or it can be possible outside the surface of the material. Usually that kind of energy we call it as electromagnetic energy, and usually the energy can be propagated by means of wave. And why should we going to discuss about this means, if you take a momentum action, for example, I have a system 1 here and have a system here. When the system I have a force here, this force has going to meet this one. It is bonded with, assume that it has bonded with this one, and usually it might be possible by uncountable bond. It might have been bonded with uncountable bond. When it has been bonded with uncountable bond, if I am giving any force, this force will be affected. This bond will be affected. Bond 1, bond 2, this n number of bonds will be affected. When these bonds are affected, this will make some vibration. So this energy, this will be propagated to here, and these also supposed to vibrate, and these also vibrate support. And then again this will be bonded by n number of atoms, and this is also vibrate. So this is also vibrate, and this is also bonded by n number of systems. So this will be vibrate. So when I am taking this trajectory, it is so called an trajectory of force transfer. This we call it as an trajectory of force transfer. So why should we discuss about this ones? These bonds are, we call it as a permeability. These bonds are, we call it as a permeability. They have already been tightly coupled. So if the bond is loosely coupled, and you can simply make a disturbance so that the energy can be portable. If the system can be vibratable, first condition is the system should be vibratable. For example, if you take a black hole, the black hole is highly bonded with each other. You cannot, if you give any signal, it cannot vibrate. The system is highly bonded. You cannot touch, not even a single momentum you cannot make. If you are giving a force and you are making a momentum, it is not vibrating means, so it doesn't affect the neighbor. It doesn't vibrating means it doesn't have the force to make it shake. It doesn't have the force to make it shake. If it cannot be able to shake it cannot propagate any signal. So if cannot be able to propagate any signal, whatever we are giving force, it cannot be propagatable. It simply stand here. It is not even reflected. It is not even observed. Because it doesn't respond. It doesn't vibrate. If at least vibrate, if it is shake, then only it will reflect and it will be refracted. So there is no reflection, there is no refraction, because it is tightly coupled. In this case of black hole as concerned, so whatever you are giving to the signal to the black hole, it simply stands as like this. It doesn't reflect, doesn't refract, but it has a highly permeability medium, because of that highly permeability medium, the bonds in the systems are highly tightly coupled. Because of they are tightly coupled, and it doesn't been supposed to vibrate. If couldn't been vibrate, it cannot able to propagate the signal, and cannot be reflection, or it can be a refraction. No refraction, no reflections. Because of this case, the signal cannot be propagatable, and it simply stand over here. So with this case, the signal has been propagated. So every system has been already been bonded with each other in the steady state atmosphere. This we call it as a steady state atmosphere. This bonds has been in a steady state atmosphere. Under a steady state, the object in each and every object are tightly bonded with every part of every object in the systems. That we call it as in steady state systems. Under the steady state system, they are clearly tightly bonded to each other. With this constraints, they may be shaked and they may not be shaked. If they are zero level shake, no shaking means it's a black hole, and it can be little shaking means it can be a solid or some other material, and if it is loosely shaking means maybe liquid or gases. So their bonds are inter-object forces little, so they can shake a lot. Maybe not only in the molecular aspects and the state-wise objects, inside an atomic and subatomic also it is possible. If you take a huge one, if the atomic structure is very huge and the density is very high, so it is tightly coupled, so it's very hard to vibrate. If the density of an atom or a density of the system or a molecule or a atom or subatomic, they are tightly bonded, the density is high and they are bonded with each other with good, and we cannot make not even a single disturbance, because they are tightly coupled with each other. With this case, we cannot able to make any we cannot able to make any shaking in this case. So with this case, the energy can be propagated as like this, and I'll next I am going to discuss about is propagation of the signal by different atmosphere. Then when we are discussing about this, it's very interesting to discuss. The thing is, every scientist are amazed about this property, because we have the signal which is propagated from one medium to another medium, and after we came back to the previous medium, the velocity remains the same. It doesn't been supposed to be changed. For example, I'll have a water, I'll have a oil, again I'll have a water, again I'll have a oil. Okay, so I am giving some signal here, and this is a force I am giving. This is the force I am giving. When I am giving a force, each and every object in this case may be propagating. This is whole thing we call it as a force. It can be an harmonic or it can be a crust and trough. So the signal can be propagated, and this is a simple factor is the force transfer between the two nearby object media, object 1, object 2. This force transfer we call it as a momentum. This momentum has been continuously propagated until the energy has been killed. Whatever the energy we have generated, and until the energy has been 100% killed, the system is keep on moving from one place to the energy is moving from one place to another place by means of wave, and since the wave has been the integration of the momentum action by this trajectory. So for example, I am giving the water here, and you know that momentum principles P equal to m into v, and for example here the velocity is v1. Okay, so this mass 1 is m1, so v1 equal to p into p by m1, and if I take this is v1 m1, v2 m2, v1 m1, v2 m2. So if you take a P equal to for water, this is, and this is for oil, P equal to m2 into v2. If I define v2 equal to P into P by m2, if I define this formula as like this, I have defined is, for example, if the signal is propagating here with v1, with this one P equal to m into v is the basic formula. From this I am deriving v1 equal to p by m1, and I am taking this oil one, P equal to M2 V2, and from this I am defining the velocity as V2 equal to P by M2. If I am defining it like this, if I am defining it as like this, when the signal has been propagated here in this case, it will travels with V1, when it goes with V2, and when it came back to here and it will travels with V1, again it will goes to V2. So even this velocity is V1 is when it is traveling the air, water, it will goes with this V1. When it is traveling in the oil, it will goes with the V2. When it is traveling in the water, again it will goes with the V1. So the velocity doesn't change. So that's why the scientists and everyone is amazing about it. But the basic characteristic is as like this. So velocity doesn't change because of this mass is changing. When the mass is changing, the velocity when the mass is changing, when the mass is changing, the permeability, the velocity will change. When the mass is retained back the previous mass, because mass is nothing but, what is the mass means? Mass of an molecule or maybe atoms. So because of the molecules and atoms, the R molecule mass is same here. Here molecules of oil molecules and water molecule and water molecules is same here. So because of this, the permeability has been keep on changing in this case. So when it is returned back to the oil molecules, velocity is same. When it is came to the water molecule, the velocity is same by this case. And when you are discussing about this, and if I take a momentum action, we have n number of atom. So when assume that this wave trajectory is like this, I am giving a signal to here, and the signal maybe signal or a force, we call it as force. When I am giving a force here, and this will be propagated to here, and with one this m1 is this one, mass of this one, and velocity is v1, and this is m2 v2, this is m1 v1. So when it has been propagated from here, the momentum is, when I am giving the signal, it is keep on momentuming it. So this is, when I momentum is, this is same molecules, this masses of this molecules are same, there is no difference. So in those case I call it as an homogeneous momentum. This we call it as, this region we call it as heterogeneous momentum. In this case I call it as an heterogeneous momentum. In this case I am call it as homogeneous momentum. In this case all the molecules are same type, and so the signal propagation, there is no problem. Here the system there is a system changes. Because of the system changes, masses also changes. Because of the mass changes, the vibration, the system inter-object vibrations, because their permeability is different, because their bonding is different. So this bond is less, and the earlier bond is only this 3, and but here this bond is extremely tightened. So because of this permeability is high and this permeability is low. So when it transfer from this to this, it is very hard to vibrate, but it is very easy to vibrate. Hard to vibrate. So because of that easy to vibrate, the signal is propagated in the same aspects. If it is hard to vibrate, this will be propagated with this velocity. So this is the velocity is like this. When this system to this system, we call it as an heterogeneous. So in this case, when it has been propagated, we will experience the reflection as well as the refraction here. When it is experiences, the signal will be reflected. When the signal will be reflected, and also it will be refracted. So the signal has been propagated over here, and when it is reaches here, it will take a homogeneous trajectory, and then when it changes to here, again the angle will be changed, and it is go through this one by this case. Next thing is, when you are discussing about this one, permeability, next thing is permeability. In this case of electrical permeability, if you are talking about electrical domain, Permeability, they will be call it as a mu will be B by H. This is magnetic flux. So this ratio will be termed as this permeability by the electrical case, but usually the permeability might be some more aspects of the electrical property, and we should have to describe clearly by this case. We have many questionnaire on this case. When you take this magnetic, when we take the magnetic permeability, it might be related to magnetic fields. When we are taking about this magnetic fields, with this magnetic field we will experience the magnetic permeability. In electrical we experience with this magnetic flux with the magnetic field permeability by this case. Yes, next thing is about this force. When we are discussing about the force is nothing but it is not fully crystallized. We have Newton's law of 1, 2, 3 only. That is not good enough for this case, because the force is a virtual physical factor. Force is a virtual physical factor which is between the two, before the 2 or n number of objects or maybe infinite number of objects, and these forces are virtually bonded to each other, and we doesn't know what is the trajectory, how they are bonded, what will cause us, how it are binded, which will integrate and make a force in this case. So we have to do much more diagnostication about the force, then only we can go for the maximum luminal or beyond the luminal velocity we can go. But this Newton's law 1, 2, 3 is not sufficient for us regarding this force as concern. We have to go for a much more, in this case of force as concern, we have to take a big velocity. We have to diagnose much more about the force as a virtual factor which will integrate 2 or 3 forces by means of attraction or repulsion, and even this attraction repulsion is possible in the every kind of aspects, starting with the mechanical, with the electrical and magnetic. Even we are experiencing the last topic is mechanical will also experience attraction as well as repulsion. That's why the atoms cannot be integrated together and they kept us with a certain distance. If you are further we are extending it to make it integrate, we cannot do it. If they are supposed to we have only attractive forces, the object will be integrated and the atoms, molecules will be integrated and the atoms will be integrated, electrons and the atom nucleus are going to be integrated, so everything will be integrated. There is no universe, there is no systems. Since there is a repulsive force, that's why we are living with this, the universe is being here and we are living and the system is living ahead. Or else if we don't have a repulsive force in the kinematic, we don't live. So we have to discuss much more. We have to identify how the factors of this repulsive force and also the attractive force, and also we have to clearly classify what the force between these two systems and how they are bonded, what will makes us to bonded, what kind of system will makes us to, what kind of system will makes the make the virtual bonding between this two objects by means of force. So the force has to be clearly defined. And next thing is, and similarly in this case of permeability as concerned, the permeability is also some kind of object, they are tightly bonded together. So they are tightly bonded together. So they are tightly bonded with the meshing aspects. If they are meshing, by the meshing aspect they will be tightly bonded, and this is by under the steady state value. Under the steady state they are tightly bonded. That's why we call it as a potential energy. It's like a potential energy. Because of the potential energy they are tightly bonded to each other. So this we termed as an permeability by this case. Okay. So when we are discussing about the permeability as this concern, this permeability is possible in electrical, mechanical and magnetic. So everywhere it is present, and we will see one by one. First I took an electrical aspects. The permeability in the electrical is possible in every part of this electrical systems, active and passive devices. It is possible in every part of the active and passive devices, the permeability is possible. And if you take up, we will discuss about some passive devices by this case. So for example, if I take a diode, it has a P, PN or NP like this, any kind of systems. Okay, so we have connected this one with battery or something like this, or something, anything, and we will experience this depletion region. There we experience this permeability. This permeability is a temporary permeability. This depletion is a temporary depletion. When you are giving a signal from the negative reverse biased, it will be the depletion region will be increased, since the permeability will extremely rise, so that it cannot able to propagate the signal from here to here. When it is in the forward bias, the depletion region will be reduced, and it cannot be, it will simply, it can propagate the signal. So here in this case, the permeability will be good enough to propagate the systems. So the permeability will also decides the signal propagation of the signal over this depletion region. So permeability is one the important factor which will, that the permeability of this depletion region will decides, permeability of this depletion region will decides. Will decides current flow or not. So this permeability will of this depletion region will decides the propagation of this current is possible or not by this case. And next thing is, if you take an capacitance. So we have a two plates. We have a two plates, plate 1, plate 2. I am not much good drawing. I didn't draw a much more good one. So these two plates are this distances are. So if you take this in capacitance, will experience the dielectric medium. This is a vacuum or air or any dielectric medium. So permeability of this system, mu will decides the propagation of this current, whether it can be propagatable or not, which will decided by the permeability of this one. If the charges are extremely good, it keep on integrating, the charges are increasing as like this, and these charges are increasing as like this. When these two charges are integrated, if the permeability of the system will mix with the signal has been propagated, if they are connected, the whole current will be propagated as a whole. So it's like an impulse. So this is a signal propagation. So it will keep on integrated. When it has been propagated, it simply conduct as one, and this is maybe if it's with respect to time. So if it is propagated, if it is cumulated, it suddenly propagates this current, whole current to the capacitance. Here also the permeability of the system which will decides this propagation of the current or not by this case. And if you take a conductors, I have a conductor 1 and conductor 2, and this conductor will decides this whether the permeability in this one, between the conductor. Here I will have a current here, I1, I2. Here I will have a current I1 and I2, and this is the permeability of this air medium or vacuum medium, any medium or dielectric medium. This permeability will decide this the attractive force between these two. So this is will decide the the propagation of this interaction force between these two systems will be decided by this permeability of the systems. If you take a transmission line, it's a transmission line is nothing but in the electrical. If you take an electrical engineering, if you take a transmission line, they transfer this line by 3 phase or like this. When they are transferring it, this among these two distance there will be a capacitance, and this whole line will act like a capacitance. And also here this will be act like an inductance also. So it is an LC circuit by this case of end. It has an inductive property, it has a capacitive property. Within these two aspects, they are inclined by around 120 degree each other. So if they are each other if they are integrated, they inclined by 120 degree each other, they will experience there will be small potential difference between these two, one phase angle difference. Because of that phase angle difference, they will have a force between these two based on the air medium, because in the transmission line the air medium will decide this permeability. Air medium will have a permeability, and this will decide this force between these two objects. So if you take two conductors, there will be a capacitance here, there will be an inductance. Inductance is like a magnetic kind of permeability. Capacitance is nothing but electric kind of permeability. So in this case of this one, capacitor will experience the electrical kind of permeability, and inductor will experience this magnetic kind of permeability. So this kind of permeability is possible in this case of every kind of electrical system as concerned. So if you take a transistor or diode or thyristor or SCR, everywhere the permeability of the dielectric medium will decide this system to be switched on or switched off by this case. So this will be very useful for us to discuss about this much more into this one. Okay, next is in this case of universal aspects. In this case of universal aspects, every system in this universe has been tightly bonded to each other. This is like a meshing force among the systems. The whole system in this universe has been meshed, and they are bonded already, and this bond we call it as permeability, we call it as G, and this is already been bonded with each other, and so this system is already been clearly bonded. So that will decide this that will already be in the it's like a potential energy, and this has been already been present in this case. When you take a solar systems, I'll have a system. So if I have a solar system, I'll have a system as like this. It has bonded like this. When it is heated and it goes to expanded, and they are loosely coupled. When they are loosely coupled, and here they are tightly coupled, and they are loosely coupled by means of heating. When they are loosely coupled, R will be raised. When R rises, permeability mu will be reduced. Okay, inter-object force is reduced. When the mu and R is reduced, the force is reduced. So when the R is raised, since Fs is equal to mu into m1 m2 by R square. When R increased, when R increased, and the mu will be reduced. When is this case? So this too will decide F will be reduced. So when it is F is reduced, the permeability will reduced. So permeability will be reduced. When the permeability is reduced, they will be expanded. Again they are supposed, when it is expanded, they will get supposed to gone for a cooling aspects, because intra-jet force and rigid force and intermagnetic fielding impact is reduced. So again they are supposed to be cooled. They are supposed to have gone for cooling. Again they will come for certain distance. After this they are supposed to be heated. It's like a cyclic one. So if you take a solar systems, and this process has been keep on going on in every part of this one. And next thing is, in this case of galaxy is concerned, if now the solar systems in this, let us take our simple solar system by sun. When sun is heated, now sun is heated by this helium ion nuclear fusion reaction. Fusion reaction. When there is a nuclear fusion reaction on the surface of the in the surface of the sun, if you experience this helium and fusion reaction, it will experience a very huge heat. So the even one we have to realize it, every system in the universe is heat absorbing system except a few, likely to be a stars. Sun is one of the stars, and except the stars, every system is keep on absorbing the heat. For example, if your sun is not giving 1 week of light to the earth, the whole earth will be, every one human being will be dead, because sunlight is very important for us. We feel that sunlight is not good, sunlight is not, but when we are considering about this, if the sunlight is not came to our earth for 1 week, whole human being will be died. No species in the world is died, because the temperature is go beyond this, less than 150 degree to every day it will goes for 150 degree less by this case. So by the every day it will goes for 150. If it is go for 150 or 200 degree less, everyone will be died. So this is sun is a important factor. So let us come to the topic. If the sun is heated a lot, there will be nuclear fusion reactions. Because of the fusion reactions, the whole stars in the solar system is absorbing this light. Okay. So in this case, let us take this one. In this case of when an object has been heated, it will be expanded, the permeability, the inter-object R will be reduced, increased, and permeability reduced, so the force is reduced, so this will be cooled a lot. When it is expanded, there has to be magnetic field of interactions, magnetic field interaction of this each and every object. So if the magnetic field interaction is less, they will be getting cool and they will be getting strict on this case. So in this case, let us come to here in this case of earth as cons, we have a nucleus and we have a heavy force by here. Because of mass we are adding here, the force is adding here. When it is adding, it's when you are going beyond this one, here the temperature is, because of the heavy mass, the system is coupled a lot, so there will be heavy mass. Due to the heavy mass and the heavy pressure crust, so there is a magnetic field interactions, magnetic field cutting of these each systems. Because of that, they will be heated and they will be heated a lot. Further, there is even though it is a liquid format, there is a further crust. Because of the crust, they are in the high pressure. Because of the high pressure, the object distance is high pressure with this dense C1, heavy dense. Because of that heavy density, they are tightly bonded to each other. Because of heavy dense, they are tightly bonded to each other. They are bonded tightly by manner. In the earlier in the normal aspect it's a bond, but here tightly bonded. Because of the tightly bonded, they will not supposed to vibrate. Since they are not supposed to vibrate, they will supposed to make a black hole. Similarly, this kind of force is possible in the center of the universe. In the center of the universe, the forces are heavy. So in the center of the universe, the inter-object distance is extremely, they are tightly, because of high pressure and high force, they are tightly close to each other. Because of that close to each other, they are highly tightly bonded to each other. Because of they are tightly bonded to each other, they cannot, whatever the force you are giving, it doesn't vibrate. So it is hold like this, it cannot vibrate. Since it cannot be vibrate, whatever the signal you are giving, it's not responding. So if it is vibrate, then only we can experience the reflection or refraction. If it is not vibrate, it's just hold like this, it's keep on holding. So its system is like a rigid one, so it cannot vibrate. In those case, we call it as a black hole by this case. And in this case of, so this is the black hole. So permeability, so in this case of black hole, the permeability of the system is extremely high, beyond the limit, beyond the tolerance value. In those cases, it's like a black hole. It doesn't mean accept, it doesn't vibrate, it's like a fully rigid one. In those cases, that we call it as a black hole. So the permeability we have discussed much more in this case. So in this case of mid of this in the black hole, they are highly bonded to each other. In this case, the meshing of force is very high and they are tightly bonded. In this case, the mass is extremely high. With these aspects, the permeability is extremely high. Even this is what we are diagnosed up to now. If you have further discussion, if you have some other discussion, further aspects in this our idea, we'll discuss in the next lecture. Thank you. Bye.